Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic, that is sulfate attacks on concrete. When the sulfate is coming in contact with the concrete, what is happening, what is the chemical reaction, what is the detrimental effect on concrete, and what is the best practice, and what is the IS code recommendation. I will discuss each and everything in this video, so stay tuned until then to get the full information about the sulfate attack on concrete. So let's jump into the subject. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting a time, let's jump into the subject. That is, today's topic is sulfate attack on concrete. Now, concrete is either exposed to the environment or inside the soil. So soil has also the sulfate content, the water is also sulfate content, in the moisture also there is sulfate. So it is a possibility that sulfate ion can penetrate inside the concrete and it is causing the harmful effect on the concrete. So let's jump and break down one by one. First, we need to know what is sulfate effect on concrete. That means sulfate attack occurs when concrete is exposed to sulfate ions, primarily from soil or water containing sulfate salt. So this can be in the soil, this can be from the water in the concrete itself, or water from the outside sources. So wherever the possible sources is there, that is, if the soil is containing the sulfate content, this sulfate react with the hydrated cement compound, leading to degradations of the concrete structure. So in the environment, in the soil, in the water, there is a sulfate ion. Now, if this sulfate ion come in contact with the hydrogen compound of cement, that is concrete, it start reacting, and if it is react, there is a detrimental effect. This is called the sulfate attack on the concrete. Now, I understand what is sulfate attack on the concrete. Next, we need to know what is the chemical reaction. What is happening exactly, that whenever the sulfate is coming inside the concrete or in coming into the contact with the concrete, the primary reaction involves in sulfate attack is the formation of ettringite, a compound that forms due to the reactions between sulfate and hydrated calcium aluminate in cement. This what is happening? It is reacting and it is forming a ettringite. This is a compound usually found when it is coming into contact with the soil. So, what is the general reaction? C3A, this calcium aluminate plus SO4 are the sulfate ions, then calcium hydroxide plus water. So, it is very much important that if the water is not present in this reaction, so this reaction will not happen. So, not only the sulfate and ion, the water is also important. So from where it is water is coming, from the soil, from the groundwater, or from the environment, the water is coming along with the sulfate ion, this reacting each other and a tringite is forming. What is the formula? CH6Al2SO4 3OH12 to 26H2O. So this is the compound salt is forming in between the reaction between the calcium C3A calcium aluminate plus SO4 and the water present in the water, or in the in the concrete or in the moisture. When it is come in these three in together, this reaction is happening. So another reaction is also happening, but this is the primary reaction that this ettringite is forming. Now, what is the effect if it is forming? I will come later. When this ettringite is forming, what is happening inside the concrete and why it is detrimental for our concrete structure. So another reaction is also happening, that's gypsum formation. Another reaction involves the formation of gypsum, which is also contribute to the expansion and cracking. So what is happening? Calcium hydroxide plus sulfur ion, it's called CaSO4 true H2O, that is a gypsum. So this is also the ettringite is happening, and this is also can happen that gypsum is forming. So both are is expanding, and if it is expand, the volume is increasing inside the concrete and it is expanding, cracking, and if the cracking is there, that means our concrete structures durability is in a problem. So This is the chemical reaction actually is happening when the sulfate is coming into the contact of the concrete along with the water. Now next, what is the harmful effect, why it is harmful, that we need to know. The first thing is expansion and cracking. The chemical reaction causes the concrete to expand, leading to cracking and loss of structural integrity. So what is happening already with so that either is gypsum is forming or maximum times the ettringite is forming. Both are increase in volume, and whenever increases volume, internal stress is developing, and when the internal stress is developing, the crack is generating. So what is happening, the crack is generating, that means concrete is not as per our requirement, and whenever the crack is there, this become the weak spot to penetrate more water, more chloride, more sulfate, more other ions, carbon dioxide, which is also a problem for the concrete. So it is a durability concern, and the structural stability is a problem. Then loss of strength, the internal reaction weaken the concrete, causing the reduction in strength and durability over time. So whatever the compound is forming in between the chemical reaction, the water and cement, this become the hardened paste. Now whenever sulfate is attacking, again this chemical reaction is happening and ettringite is forming. So what is happening, the main component is become weaker. So if it is weaker, then our strength and durability is also a problem. Then surface cleaning and spalling. What is happening? The concrete surface may flake or spall up due to the internal stress. Sometimes it's happening. What is that? That not only the crack is generating, also whenever it is expanding, the spalling is happening and concrete is fall from the surface. So this caused by the sulfate reaction also. Then it is a disintegration. Prolonged exposure can lead to severe disintegration of concrete, particularly in foundation and underground structure. So what is happening, disintegration is happening, again it's a durability issue. So what is our motto, to get the concrete strength and the concrete durability, so that whatever I plan for the concrete structure, that we need to perform. But if this sulfate ion is coming and a sulfate attack is happening, this become the problem. Then loss of durability, as we discussed, as cracks develop, moisture and other harmful chemicals can further penetrate. That already discussed. If carbon dioxide is penetrated, this carbonation is happening. Again, the carbonation is happening. Then again, it's a problem for the durability and the strength. If chloride is happening, that also its chemical reaction is happening. Water is increasing, chloride is increasing, the reinforcement will be corrosion, corrosion will be there. Again, this is a problem for the durability and the strain. So this is weaken the durability, it's a durability concern. Then reinforcement corrosion, that already discussed, that cracks allow water and oxygen and reach to the steel reinforcement, leading to rusting and weakening the steel. So these are all the things which is the parameter of a concrete for the long lasting structure, for the durability. But if the sulfate is attacking on the concrete, due to this chemical reaction, this all phenomenon can happen, which is or not only losing the concrete, which not only reduces the strength, the durability is also is a constant. So it's a very harmful effect. We need to take care very much to protect our concrete. In the next year, I will discuss about what is the remedial measure. The first remedial measure is use of sulfate resistance cement. Now there are different types of cement available in the market. So there is a cement also called sulfate resistant cement. What is that? It is when a sulfate is coming, that is it is resisting the sulfate attack. So what special sulfate resistant cement should be used in areas where it's exposed to sulfate attack. This type of cement has low alumina content or C3A, that we already discussed, that C3A is the main component. Whenever the sulfate ion is attacking, so this react with the C3A. So in the sulfate resistant cement, there is a low cement, the low content of C3A. Then low permeable concrete. So it is our motto that the concrete should be low permeable. Why? If the permeability is low, that means this all carbon dioxide, sulfate, chloride, and moisture cannot ingress or cannot penetrate inside the concrete. So it is our motto to make the concrete less low durable, or sorry, low permeable. Reducing the permeability of concrete helps prevent the ingress of sulfate, not only sulfate, carbon dioxide, chloride, or everything. So it is help the durability and the strength. Then it is also important that proper mix proportioning increases the water cement ratio, and using pozzolanic materials like fly ash or silica fume can help reduces the vulnerability of sulfate attack. So nowadays in the mixed design we are using pulverized fuel ash, GGBS, microsilica, that also that is called the supplementary cement material. So this also has the good conduct good way to reduces the sulfate attack. Then good quality of aggregates, it is very much important to use the good quality of aggregate inside the concrete. Why? Use high quality non-reactive aggregate reduces the potential to chemical reaction. So there are some aggregates which is highly reactive, so they also react with the concrete, and they make this concrete not durable or strength is reducing. So it is our duty to find out the non-reactive aggregate. So there is another phenomenon is happening, that is alkali silica reaction. If there is the reactive silica is there inside the aggregate, so what is ASR and everything, I made a detailed video, link is there or in the description, please check, you will get the full information. Then one layer of protective coating, it is a very much useful and widely used, that applying sulfate resistant coating to the surface of the concrete can reduces the exposure to the sulfate. Then proper drainage system, now it is very much important that there should be a proper drainage system in the concrete, so that there will be no accumulation of water. If there is no accumulation of water, water will not penetrate inside the concrete, and without the water, no reaction, not only the sulfate attack, chemical carbonation, also the chemical chloride attack, nothing will happen if there is no moisture or no water. So it is very much important to provide the adequate drainage system or the slope, so that there will be no standing water and there will be no accumulation of water inside the concrete. So these are the remedial measure we can take to prevent sulfate attack on the concrete. Then now next, what is the IS recommendation for the sulfate resistance concrete? So in IS 456 in table 4, it is given, yeah, what is the recommendation? This requirement of concrete exposed to the sulfate attack. So what is saying here? It is a concentration of sulfate expressed as SO3 is total CO2 in soil and in water, in groundwater. Here it is given, and here it is type of cement. Here it is dense, fully compacted concrete made with 20 natural nominal maximum size aggregate is a minimum cement concrete, how much should be, and maximum water free cement ratio. Now here it is, first is ordinary Portland cement or Portland slag cement or Portland pozzolana cement. So if we are using this type of cement, and if SO3 is, where can I use this type of cement? Where SO3 is total is less than zero point 0.2, and in groundwater 0.3. And what will be the minimum cement content? That will be 280 kg per cubic meter, and maximum free water cement ratio, that is 0.55. Now if I have the condition where the soil is 0.52, so SO3 is 0.521. Now what is happening here? It is what is super sulfate cement or sulfate resisting Portland cement or Portland pozzolana cement will be used, and minimum cement content is 350 and maximum water cement ratio is 0.450. So this table 4 is very much important whenever we are doing the mix design. If we know the exact percentage of this SO3 in the present in the soil or in the groundwater, and accordingly we need to do the mix design. Here it is also given, that is if the soil SO3 is maximum 1.1 to 2, then super sulfated or sulfate resisting Portland cement can only be used, and minimum cement is 370 and maximum water cement ratio at 0.4. So whenever you are doing a design, and you should consider the sulfate attack on the concrete, and accordingly from the table 4 you can find out what will be the maximum water cement ratio, what will be the minimum cement content. Accordingly we can make the mix design. So this table is very much important whenever we are working in India. This table is very much important whenever we are designing concrete in an area where the sulfate is a problem. So use this table and you will make a mix design proper, so that there will be no sulfate attack. And what is the permissible limit of solid for the water? This is also given in sulfate, that is is rigid 4000 milligram per liter. So whatever the water we are using, that is also has the limit. This is the all for the sulfate resisting cement. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And thank you once again for watching me.